3D printing is one of the most cost-effective production methods for prototypes and low-volume or custom end-use parts. 3D printers don't require expensive tooling or lengthy setup, so they can produce parts that cost up to 95% less than machining, molding, or outsourcing to service providers. But when comparing the cost of different 3D printers and accurately calculating the cost per part, there's more to consider than just sticker prices. Materials and labor costs are important to factor in when evaluating cost per part. In this video, we'll compare costs for the three most common 3D printing technologies for plastics: FDM, SLA, and SLS. Fixed costs, such as the cost of the 3D printer, service contracts, installation, and maintenance, make up the equipment ownership cost. These are costs you need to pay regardless of whether your printer stands idle or produces hundreds of parts a week. Generally, FDM 3D printers offer the lowest entry cost to 3D printing. SLA 3D printers offer better part quality, higher accuracy, and access to a wider range of advanced materials, but can carry a slightly higher price tag. SLS 3D printing is most often used in industrial applications. It has become available in smaller, more affordable benchtop solutions, but it's still priced considerably higher than both FDM and SLA ecosystems. Calculate a rough per-part attribution for these costs by adding up all of the forecasted fixed cost over the lifetime of the machine, and then divide it by the number of parts that it is expected to produce. Equipment ownership costs can become almost negligible when you divide it among the thousands of parts a machine can produce over its lifetime. Material costs will vary based on the size and number of parts being printed as well as the materials used. When calculating material cost per part, multiply the amount of material required to create a single part by the cost of that material. For FDM and SLA, include the volume of material used to create support structures as well. Filament for FDM printers is inexpensive, with budget options starting under $20 per kilogram. Parts can be printed with an interior lattice or infill to save material and time. However, solid parts are more expensive, and complex designs with overhangs require a lot of material for supports. Resin for SLA printers varies widely in cost. Low-cost options exist, but often contain potentially harmful chemicals and have limited options for material properties. Higher-end resins carry a more premium price tag, but include a wider range of mechanical properties and access to advanced chemistries like silicone and polyurethane and biocompatible materials. Powder for SLS printers is generally used in large enough volumes that there are discounts available for bulk purchases. Since parts print without support structures and uncintered powder can be reused, material cost per part tends to be even lower than a direct comparison of price per kilogram would suggest. Any manufacturing cost estimate must take labor into account. While 3D printing can replace the complex workflows of traditional manufacturing methods, it can still be a fairly labor-intensive process. In most cases, setting up and maintaining FDM printers is fairly easy. For specialty materials, fine-tuning print settings can take trial and error. Post-processing can be fast if parts are simple or when using soluble support material, but manual support removal can be time-consuming. So post-processing FDM prints to have a presentation-ready surface finish can be a lengthy process. When it comes to setup and maintenance, SLA printers are comparable to FDM. Post-processing for SLA includes washing parts in a solvent and, depending on the material, post-curing the parts. However, these steps can be automated to minimize time and labor. Thanks to light-touch supports, support removal is quick and parts look presentation-ready with minimal finishing. SLS 3D printers require more involved setup and maintenance than FDM or SLA. However, as both depowdering parts and media blasting can be mostly automated and there's no need for support removal, SLS is the least labor-intensive and most consistent 3D printing process, especially for larger volumes of parts. To sum it up, FDM has the lowest barrier to entry when it comes to both the cost for the printer itself and cost per part. SLA offers premium part quality at a slight premium cost. SLS is the most cost-effective process for producing medium to large volumes of high-quality functional parts, but the upfront cost is much higher than with FDM or SLA. Cost will differ between manufacturers, models, and depending on your application. Make sure to ask about printer, material, and labor costs before making a purchase. If you're considering 3D printing, cost isn't the only factor. Check out our other videos on print speed, quality, materials, and ease of use to learn more.